So again, what we have worked with so far are they go by different names. Simple variables, scalar variables, elementary variables. But every variable we've created, as far as I know, every one so far has had only one value in it. All right? So, I've given this example before, and maybe it's not a great example, but imagine it was the first day of class. And let's just say this room was filled with people. Okay? And I came in and I said, hey, sorry, I'm running late. And I gave each one of you a little Lego. Literally, just a Lego. And I say, hey, just amuse yourselves. I'll be back in 10 minutes. Let's face it, with a Lego, there's only so much you can do. All right, but if there were 20 or 30 or more of you in here and you put all your pieces together, you could make something eventually. It may not be beautiful or whatever, or it might be. All right, I guess there's some new TV show coming on Fox. I saw a commercial for it during the Super Bowl for building Legos. All right, what's that? Yeah, and but the point is, if you take a bunch of simple or elementary data items and you put them together, it's referred to as a data structure. So an array is the first data structure we're going to talk about. In this chapter, they talk about two of them. They talk about arrays and they talk about lists. We're going to talk about both. All right, now this is a fairly long chapter. It's about 40 pages. So we'll take our time with it. And if we only get through the first half or whatever today, it's no big thing. All right. What I am going to ask, and I'm going to give you a piece of paper later with this on it, but what I'm going to ask that you do for tomorrow is to make this. Okay. Now, you may have not seen this before. It's called a list box. It's just going to hold a bunch of values. Okay. And the idea is when we click here, 25 random numbers are going to come into here. If we click here, they'll all clear out. If we click here, those numbers will be put in ascending order. Clicking here, they'll be put in descending order. Clicking here, it'll come up and it'll say, search for a number in the array. So I can put in 37. And if 37 is there, it'll say 37 exists at position 6. All right, and if 37 is not there, it'll say 37 is not in the array. All right. This, as you guess, will bring up the message box saying you want to exit the program. This will add all 25 numbers up and show us the sum. This will add all 25 numbers up and divide by 25 and show us the average. This will show us the lowest of all the numbers, the highest of all the numbers, the median of all the numbers. So it'll put them in order and it'll grab really the 13th because that's the one in the middle. All right, and this will be the range. So these will be 25 random numbers between 1 and 100. So if our smallest number was 6 and our largest number was 90, 90 minus 6 is 84, that would be our range. Does all that make sense? I'm going to give you the code for it tomorrow. But I think it's a really good way to introduce and start working with arrays. We're going to build a subset of this today. It's going to be a console program, so it'll be ugly, but that's fine. And what it'll do is basically it'll show us 25 random numbers, then it'll put them in ascending order, then it'll put them in descending order, then it'll show you the lowest of the numbers, then the highest of the numbers, then the sum, and then the average. So it'll be, like I said, a subset, so to speak, of this. Does that make sense? All right. So again, I don't want to sit and read to you or anything else, but as it says, arrays and collections, they're containers, so they can hold multiple values. The difference between an array that we'll look at and what's typically referred to as a list, which I thought was in here, but I will at least talk about it, is an array. Once you make the size of an array, you can't change it when the program's running. So if we say it's got 25 numbers, that's what it's got. With a list, you can add things, remove things, and make it bigger and smaller as the program's running. So when you look at it, that's more reminiscent of real life. Because if you're working for a company constantly, probably a company of any size, has employees entering the company and leaving the company. All right? So we're going to get into all that stuff later on. All right. So it says in this chapter you'll learn the basic concepts and techniques for working with arrays and other types of collections. So what I would like you to do is please start up Visual Studio. All right, everybody. So start up Visual Studio. Now I've written it already, so yeah, you can call that my cheat sheet or whatever. There's about, I don't know, 140 lines in here. So we won't even get it done by the time we take our first break. Again, the idea is, I don't want to sound like a, he's a big cliche guy, but it is a marathon, it's not a sprint. I'd rather get part of it done today or all of it or whatever and keep working on it tomorrow and have you say, oh, I get it, than see how fast we can go through this. Hopefully that makes sense to everybody. So start up Visual Studio, create a new project. You've done this before, so you know how to do it. All right. We want it to be a console app.NET framework, so make sure that's the one that's chosen, console app.NET framework. Once you've got that, click Next. We are literally going to call this Array Console. Okay. Make sure that in your location, change it as necessary. For me, again, it's on my desktop. All right. For you, it's wherever you typically save these things. All right. So again, Array Console, one word, big A for array, big C for console. I'm saving mine to my desktop. You save yours to wherever you typically save these things. All right. And once you do that, click Create. And you should have this when you come up. Okay? Now, just so you know, I don't know how many variables we have, maybe a half dozen or so. I made all of them global. What that means is if you look on the screen, I define them here. They are defined outside of main. Not only that, I modularized this program. I purposely wrote it so that it was called routines to do different things. But it's very English-like. In other words, I want to read you the name of the modules we're going to create. Fill the array. Print out array in original order. Sort array, print out in ascending order. Reverse array, print out in descending order. Print out largest array element. Print out smallest array element. Calculate and print out sum of all array elements. Calculate and print out AVG of all array elements. Does that make sense? So anybody could look at this program and figure out what we were doing at any time. All right? Okay. Now, I didn't put in, actually I guess I did. I put in one constant. All right? And I said in here, const int max equal 25. And I said that's the max number of array elements. And if you say to me, I don't even know what the heck an array element is, it's okay. We're going to talk about it. All right? All right. Then I'm going to put in, like I said, 1, 2, 3, 4, 5, 6 variables. And everything that we're doing here, all right, everything that we're doing here, namespace cannot directly contain, what does it look like here? Constant max. Oh, okay, my fault. Move these down. They've got to go right above main. So put them under class program. My error. Move this down so it's right under the curly brace for class program. That was my error. All right. So now we're going to add 6 variables. Again, I tried to make this and come up with variable names that were virtually as self-documenting as possible. Okay? Not just in the variable names, but the names for the routines, etc. Everything that we did. All right. So First one, and they're all static because they're all defined outside of main. But they're all going to have to be used in main. So I said here static, int, bracket, bracket. That's how you show that something is an array. All right, we're going to talk all about these later. But we're going to talk about arrays, brackets, everything that's involved in here later. All right, and I called my array numbers, and I set it equal to new int max. All right, so just for a minute, imagine that we've got, we're at an apartment complex, and that apartment complex has 25 mailboxes in it. Okay, it's 123 Main Street. There's probably a pretty good chance that if I live in that apartment complex and somebody puts something, Jeff Scott, they say 123 Main Street, if on each one of the mailboxes there's a little thing with names, it'll go in the right one. Would you agree with that? But there's a better chance if somebody would say, if I'm in apartment 16, if they say Jeff Scott, 123 Main Street, apartment 16, there's probably a better chance that I'll get it. I didn't know this until we had been in the house that I'm living in Lake St. Louis for about 6 months, but it was a rental. There have been 8 different people I get mail for still on a regular basis. And one lady's been called for jury duty 4 times. My wife finally called down there and said, she hasn't lived here for a year and a half. And they thanked her for doing that. All right. So what we're doing is we're making our own mailbox, so to speak. It's going to have 25 of these mail slots in it. The name of the entire mailbox will be numbers. And the only thing we can put inside of those mail slots are whole numbers without a decimal point. The first mailbox will be mailbox 0. The last mailbox will be mailbox 24. I've said this before. I don't think this is funny. But when I got into this, one of the first jokes I heard as a programmer is ask a programmer to count to 10. And it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right? Because you always start at 0. And this is another case where that's the case, so to speak. All right, so I'm just going to say here this is the numbers array. All right, and I'm going to put in another static int, and I've got to have a variable here that's called smallest. And I'm going to set that equal to 101. Very similar to what we talked about the other day. All right. Why am I doing that? Because it is the smallest. No, it will be the smallest number in the array. All right. It will, in just a minute, be the smallest number in the array. So, smallest, typically what we call the smallest array element. All right. And if we've got a smallest, you may have already guessed, we're going to have what happened there? We're going to have another one that's going to be called largest. All right. We're going to set that one equal to, in fact, let's make it -1. And again, this will be the largest array element. Now, I'm to the point, what happened here? I don't know what happened here. All right. I'm to the point right now where I just want to make sure you understand what we're doing. So imagine that we have, I'm not going to write all of them, but just imagine we have 25 numbers. Let's say they're test scores: 37, 63, 100, 85, 41. Let's pretend there's 25 of those. You with me? All right, so boom, 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 boom. The 25th one's a 99. So looking at this, this will be the smallest, this will be the largest. Does that make sense? All right. Right now, they're not in any kind of order. So if I had 25 of you in here, maybe they'd be in alphabetic order. But maybe later I want it in highest grade to lowest grade. or maybe I want it from lowest grade to highest grade. Again, I probably have told you about this already, but I still remember that my old math teacher used to hand back tests, and he'd do it from highest grade to lowest grade, and I always got mine last. All right? That's when people go, do I need to know math to be good in computers? It helps, and I've gotten better at math during the years. All right, but it's, again, it's recognizing patterns and things like that matter. All right, so we've got a smallest, we've got a largest. Let's make another one. Sum, and we'll set that equal to 0. And I'm going to put here sum of all array elements. All right, and another one. This one will be a double, and it's going to hold the average. All right, and I'm making it a double so that it'll be a true average. So if the average is a 53.47, it'll say 53.47. It won't say 53. Does that make sense? We could round it up or down. I don't want to do that. We're going to make our average in the end. We'll probably make it to two decimal places. All right. Finally, I'm going to have one last variable. I don't need this one because I could make it as I'm going along, but I'm going to call it out_str. All right. What does that mean? It's an output string. In fact, now that I look at it, I called it output str. Sorry about that. And that's equal to nothing. So this will be a temporary output string. No, I spelled temporary wrong too. Temporary, I think that's right. All right, we're putting one more variable. We want to be able to create random numbers. If you want to be able to create random numbers, you've got to put a line in similar to this one. And it will say static, random, equal, new, random. Now, when you put that in, I don't expect that's going to make a lot of sense to you. All right, so I put in a comment there, but again, that comment that's there may or may not make sense to you. And if it doesn't, don't worry about it. Because what we're doing for the first time in this line right here, I think it's the first time, is we're working with object-oriented programming. All right. Basically what it says is when you work with random numbers are part of the random class. So we're making a new instance of the random class with a big R. We're calling it random with a little r. We could call it Betty. It wouldn't matter. But since it's random, typically that's the way that you do it. I'm working with stuff with the second year people, and we're working with something that are called intents. INTENTS. So we usually go intent with a big I, intent with a little I, equal new intent with a big I. So this is quite often the way that you would do things like this, is what I'm telling you. All right. So what we're going to do in here is we're going to make a call to a routine. We're going to make a call to a routine, and guess what? The routine doesn't exist. So we're going to get an error. So right under this, we're going to write the routine. Then we're going to jump back up into main again, write another routine that doesn't exist, so we get an error. Then we'll write that routine. And we have 1, 2, 3, 4, 5, 6, 7, 8 routines. When we're all done, we'll put a read line into main. Okay, but what I want to do is I want us to write a routine, check it, make sure it works, put the reline in there, then write the next routine, check it, and make sure it works. Again, I haven't done nearly as good a job as I should in mentioning that and imploring you to do that. What I don't want is, you'll take a test next week. I don't know. You might take several tests next week. We might test on 6 and 7. I don't know. But the point is, when you take a test, what I don't want you to do is write 100 lines of code and then start testing. Because you got errors, that's a lot of code to have to wade through. But if you write 10 to 12 lines and test it, 10 to 12 lines more and test it, you're much better off. All right. When I wrote this, and this is all me. I'm not saying this, oh, it's all me. This is fantastic. No, but I'm saying I wrote this. All right. When I wrote it the first time, I didn't do any modularization. I wrote everything right inside of main. This morning I went back in and I rewrote it with modularization. Why? Because that's where we are right now. We've gone over chapters 6 and 7, so you've learned how to modularize. All right. Now, one last thing before we keep going on. So, as we come in here then, the first thing we're going to do is we're going to write, and I'm going to comment everything we do. All right. Write method to fill up array. Okay. And here's a surprise. I call the array, or the method rather, fill the array. Okay. You should get an error just like I'm getting when you do this. If you put your mouse over it, it basically says, it's looking, what it does is it looks for a system method called fill the array. It doesn't find it. Now, what I want to show you, because we have not looked at this before, please look up on the screen, everybody. Notice I can come up here, and one of the choices that I get, come on, is generate it. So if I want the system to write it for me, I can click there, see what it does? And that is what we're going to write, but it doesn't need to be private. It doesn't hurt to make it private. So I'm just going to leave it like that. The thing is, we're not working with exceptions right now, so I'm going to remove that. The point is, if you want that error to go away, you can just choose that every time. See what I'm saying? All right. Now, I do want to mention, too, the difference between this and this. All right. I'm going to tell you what the difference is right now. You probably won't remember it, but it's okay. If I put the word private here, that means that this method can only be used from inside of this routine, anything that's in here. But remember this, where we talked about if I right mouse clicked, I could choose add and I could choose new project. Remember that? If I did that, that project wouldn't know that this exists because it's private only to the project we're currently working with. Yes. Well, if I got rid of private, which is what I'm going to do, if I did that, then if I came in here and I made another project, that project could use it. But if I change this in here and put the word public in, now you could write your, you could write your own program. And if I gave, told you where it was, you could call my stuff. So it's public. Anybody could use it. So when you think about it, you go, I don't get it. Yeah, I think you do. Because anything that's been written by Visual Basic itself, they make public. So you can use it. All right? And there's a few other things. There's public, there's private, there's protected, and there's something called assembly. We'll get into all that like in Chapter 12. All right? To try to keep it simple, though, I'm just not going to put public or private or anything in there. I'm just going to leave it as static. Now, the reason this has to be static, right here, if I put static off, this is going to end up interfacing with main, which is static. Main only knows how to work with other things that are static. All right? And if you go, I don't even know what the heck static is. Static means basically there's just one of them for right now. And we all share it. And you may have noticed this. If I go back up here, for example, and where I've got my numbers, if I remove static from there, I'm going to get an error also. These variables that are here, these variables are going to interface directly or indirectly with main, so they all have to be static. The only thing that we don't have to worry about is max. Constants do not have to be static. All right? And if you go, why? I mean, the smart aleck answer is, I didn't make the rules. That's just the way that it is. Okay? So, we're ready to come in here and we're ready to fill the array. The good news is, by writing it like this, most of these routines are going to be 10 lines of code or less. All right? So we want to come in here and fill the array. Okay. For int LCV equals 0, LCV less than numbers dot length plus plus LCV numbers LCV equals random dot next 100. I'll let you write that, okay? I'll let you put all that in, and then we're going to go over it line by line. There's only, what, 1, 2, 3, 4 lines. But we're going to go over each one of those lines in blue in just a minute, all right? And I'm going to go till about 8:55. We'll take 10 minutes, and, you know, and hopefully between 9:05 and 10, we can finish this, okay? I don't know if it makes it easier to see or harder to see if it's in blue, but at least you know exactly what it is you're supposed to type when I make it blue. So the program begins and it calls fill the array. Okay? Fill the array gets called. So what this says is I'm going to count from 0, and as long as it's less than, well, it looks for length and it says, oh, that's max, so that's 25. So from 0 to less than 25, which is 24, right? But if I count 0, 1, 2, 3, 4, 5 to 24, that's 25. All right? So what it's saying is, I want you to start at 0, and as long as we're less than the length of the array, which is 25, do this, then come back and add 1, check it, and if it's still less than 25, do it again. All right? So imagine, again, these are 25 mailboxes. Instead of an address, we're just putting numbers there. So we generate the stuff that we saw before. Again, I'll put in 10 of them. 37, 18, 61, 91, 35, 80, 90, 100. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right? So let's pretend that was only 10 instead of 25 because I'm too lazy to write more. So this one, the first time through that we go through here, LCV, this is a placeholder. It's 0. It's our first mailbox. So it's going to put 99 in there. Then we add 1 to it. So when we get to 1, it's going to put 88 in there. 2, it's going to put 37. Does that make sense? This is the hardest part of people understanding arrays. You might say, well, that's not hard. What people have to understand is this is a placeholder. This will have a value between 0 and 24. Just like I said, like with an apartment complex. If there were 25 units, they probably wouldn't start at 0. They'd probably go from 1 to 25. All right? The same kind of thing. But if you get this, that's the hardest part, believe it or not, of understanding it. All right? So when we get done, ideally, and I'm not going to write all 10 of these out, but now we'll have 25 locations, and each one will have its own random number. Does that make sense? When you use random numbers, the idea is every time you run the program, you'll get different numbers. Does that make sense? But it is totally possible for any number to repeat. Just like, if I had 25 of you in here, 5 people could have gotten an 87 on the test, right? That's possible. All right. And it's the same way here. So this, you don't have to put it in here. I'll just put a comment in here that says, fill the array with 25 random numbers between 1 and 100. Okay? Now, I didn't do this if you look on the screen. First of all, could we have made that 0? Maybe that would have been better. This isn't a test. Do you understand? These are not 25 tests. That's why I'm using numbers. Okay? But what we could have done, if you look up on the screen here, don't write this down, but we could have, if we wanted to, we could have come up here and said, we've got max, etc. We could have come in here and said like const int min number equals 1. And then we could have said const int max number equal 100. We could have done that. Then down here, we could have written min number, max number. See that? All right. I didn't think we had to, so I didn't. If you think, no, it's much easier for me to understand like that, then do it. It's no big thing. All right. But does everybody understand then when we get done, these 25 locations each have a number in them between 1 and 100. That's all we've done so far. All right. So that's the first thing. All right. Then we're going to jump back into main. And you may or may not realize it, but when we get done with main, main's totally a driver. Main's a supervisor. It says, Dominic, you do this. Maya, you do this. Keegan, you do this. Angie, you do this. That's exactly what it's doing. Rather than doing any of the actual processing itself, it's delegating authority out to each one of these 7 or 8 routines. So if there's 8 routines, imagine I had each one of you do 2 of them. But the good news is now I know if there's a problem with the array, and I know it's where the array was filled up, it has to be in here. I know that's all we've written, but I'm just saying, even as we write more, we know that's why you modularize code. All right, so that's first thing. Now, we want to come back into here, and we're going to print out array in original order. Okay? And let's call the routine print out array in original order. Again, as you can see, we get an error message because we haven't written that yet. Each of these methods that we create today, just so you know, each method we create is going to have a return type of void, meaning it's not going to return a doggone thing. None of them are. It's just the way I wrote it. Could you have done it another way? Of course you could have done it another way. All right, and that's fine. All right. So we're going to write this routine right now. Print out array in original order. So I'm going to come down and right under this one, I'm going to write down this routine prints out the numbers array in its original order. All right. Notice as soon as we do this, no errors here, and our error went away up here. If you look up on the screen, our error is gone because we've now started to write this routine. All right. This routine also, it's a little longer. I put comments in. It's 1, 2, 3, 4, 5 lines instead of being 4. It's 5, 6 with the comment. All right. You don't have to, but I just technically, since I put the comment up here, I don't even need my comment down here because the comment that I wrote down there said print out the array in original order. We already have that up on top. This, so you know, when you put a comment before a method, it's called a method prologue. Maybe you've seen TV shows where they have a prologue and then they show then an epilogue at the end. All right, the prologue means that you do it first. All right, so since I put it before that. All right, so now I can come in here, and just like we did before, we're going to do a for loop. But before we do, I'm going to use this output string. Remember this thing up here that was called output string? I'm going to use that, and I'm going to say the output string is equal to the array in original order \n. All right. Now, you might say, wait, Jeff, I got a question. You said we were going to run this as we did each one. All that's doing is filling the array. There's no print statements in there. So we won't even know if that worked. But what we'll do after this, before we take the break, but what we'll do after this is we'll run this several times so you can see how it's working. All right? So we're going to say the array in original order, and then we'll have a blank line. Then let's have another for loop like we just had up here. In fact, I'm going to copy this for loop in. I'm going to change the guts. I don't want that line in there. Did we put in our, nope, sorry, using static system.console. Remember this? Feel free to put that in. All right. And now I'll make this a little smaller. So this is what we've done so far. All right, we just did the fill array. Now we're doing this one. This is that whole routine. Blank line there I don't need, so there we go. I'll give you just a couple minutes, and then we're going to run it. If you're typing it in and you get any red stuff in here, you made some kind of an error. All right? What kind of an error did you make? It depends on what you typed in. All right? Now, I'll come right back to it. So if you're still typing, just hold on for a second. But please, if you would, look up on the screen here. Now I'm going to run it. What did I forget? My read line, right? So I'm going to go back up here into main, type in here, read line. Okay? Go back into main, and after fill the array and print out array in original order, I added a read line, paren, paren. Now when I run it, okay? Is that pretty obvious what we just did? And notice the numbers. I'm just going to read the first four. 89, 24, 25, 68. Okay? I'm going to stop the run, and I'm going to run it again. They're different numbers. See that? All right. Stop it and run it again. And again, they're different numbers. All right? So that's what we've done so far. We've said fill the array, which says generate the array with 25 random numbers. All right? And then print it out in its original order. Why do we even care about printing it out in its original order? Because the next thing we're going to do is we're going to sort the array. All right. So we won't write that one yet. We'll take our break a little early. But let's come up to here. And let's put in a comment right under where we put print out array in original order. Let's type in sort array print out in ascending order. All right, in which I called sort array print out in ascending order. Again, I get the error message because we haven't written it yet. So please put in that. And again, what you're going to find in just a minute, this is one of the longest routines. It's a whopping 9 lines. All right? But your learning modularization, what you'll have at the end is you'll have about 8 routines which average about 7 lines each. All right? So again, if I want to, I can go down here now and I can say this routine will sort the array in ascending order and then print the array. Static void. We're not going to write this. We're going to take a break in just a second. But the point is, look up on the screen here. All right. Notice numbers does not have the squigglies anymore. Max does not have the squigglies. Output string does not have the squigglies, meaning they've all been used in the program. All right. We haven't done the smallest and largest yet. We'll do that after the break. We haven't done sum and average yet. We'll do those after the break.
So basically, every variable should end up being just like numbers and output strings.
I don't know if this is what you're asking, but what we're doing is we're writing a routine for every variable that we have in here. And every one of those variables is going to use that array, and every one of those variables is going to write stuff into here. All right? And we've not done a ton of documentation, but there's a little bit here, so we know what we're calling, and there's a little bit here, so we know what we're doing. All right? So it's 8:53. Let's come back, please, at 9:05. And when we do, we're immediately going to write the sort array and print it in ascending order. I don't want to insult your intelligence, so I won't say this. But if I did want to insult your intelligence, I'd say, what's the opposite of ascending? And you'd probably say descending, right? So, you know, ascending A to Z, 1 to 10. Descending Z to A, 10 to 1. All right? Well, the reason I'm telling you this is, believe it or not, C# for arrays has a sort routine that does it in ascending order. It doesn't have a reverse sort routine to do it in descending order. Most languages do. But C# has a routine called reverse. So we just ran sort, we're going to run reverse, and that'll give it to us in descending order. Take your break.